Right now, somewhere outside, light is hitting your skin. You did not earn it, you did not ask for it. It just arrives. Every morning, on schedule, and you assume tomorrow will be exactly the same. Now imagine you wake up and it is not the same. The sun is still there, but dimmer. You can look at it directly, like the moon. The air is colder, your shadow is faint. By midday, it has not gotten brighter. Then it does not get brighter the next day, or the next month, or for the next 18 months. This is not a science fiction story. It happened. 1,500 years ago, the sky over Europe, Asia, and the Middle East dimmed. Crops failed across an entire hemisphere. A famine spread. And then a plague arrived that killed between 25 and 50 million people. Today, historians at Harvard call the 12 months it began in the worst year in human history. For 1,500 years, nobody knew why it happened. We only found the answer in 2018, and it changes what we think we know about how stable the world actually is. The first warning came from the sky. In the spring of 536, a Byzantine official named Procopius was working in the capital of the Eastern Roman Empire, Constantinople. He was one of the most careful historians of his century. He was not a man given to drama, and in the spring of that year, he wrote a sentence that historians would not be able to fully believe for the next 1,400 years. He wrote, "The sun gave forth its light without brightness, like the moon, during the whole year." A single sentence, a complete description of normal daylight breaking. And he was not alone. From Ireland to China, from Italy to Persia, every literate culture on Earth recorded the same thing in their own language in the same year. The sun had dimmed. Something was blocking its light, everywhere on the planet, at once. Modern climate scientists today know exactly what happened to the temperature. Across the entire Northern Hemisphere, the summer of 536 was approximately 1.5 to 2.5 degrees Celsius colder than normal. That sounds like nothing. It is not. A drop of even 1 degree across an entire summer is enough to kill the wheat harvest of a continent. And the dimming did not lift after a few weeks. It lasted 18 months. What follows is the kind of slow disaster that does not appear in school textbooks. Because there is no single battle and no single villain, just the gradual, silent collapse of food. Across Europe, the first failed harvest came in autumn 536. The second came in 537. The third came in 538. In Scandinavia, archaeological evidence suggests something close to a regional apocalypse. Farms were abandoned. Forests grew back over the fields. Population in southern Sweden may have collapsed by more than 50%. Norse mythology preserved a memory of this catastrophe under the name Fimbulwinter, the Great Winter, 3 years without a summer between them, that comes before the end of the world. But the worst was still coming. Because hunger weakens immune systems, and weakened immune systems are perfect targets. 5 years after the sky dimmed, in the year 541, a new disease arrived in an Egyptian port. It moved up the Mediterranean coast on trade ships. By 542, it had reached Constantinople, and there it began to kill at a speed nobody had ever seen. Procopius, the same historian who had written about the dimmed sun, now wrote about this too. He watched it unfold in his own city. He estimated that at the peak, 10,000 people were dying in Constantinople every single day. Bodies could not be buried fast enough. The Emperor Justinian, who the plague is now named after, caught it himself and barely survived. In 2 centuries of recurring waves, the Justinianic plague killed between 25 and 50 million people. The Eastern Roman Empire, which had been the strongest civilization in the Western world for half a millennium, did not recover. Within a century, the western half was gone forever, and the cities of late antiquity had quietly shrunk into the small medieval towns that would eventually become Europe. It all started in a year of dim sunlight. So what caused it? What blocked the sun for 18 months? For most of human history, nobody knew. The medieval answer was that God was angry. Different cultures invented their own demons, sins, and signs of the end times. None of it was useful as an explanation. Modern science took its first real shot in the 1980s. Researchers studying oak trees from across Europe noticed something strange. The growth ring for the year 536 was thin, dark, and sickly. The next year's ring was even worse. Trees, it turned out, were recording the catastrophe directly. The summers really had been cold. The growing seasons really had collapsed. Then, a different team of scientists started drilling into Greenland's glaciers. Ice cores are columns of ice pulled from the deep ice sheet. Each layer is a year of snow, sealed under the year above it, and each layer holds tiny bubbles of the air from that year, plus any dust, ash, or chemicals that fell from the sky. In 1984, when they reached the 536 layer, they found it full of sulfuric acid. Sulfuric acid in glacier ice means one thing: a massive volcanic eruption. When a volcano explodes hard enough, it throws sulfur gas high into the stratosphere, above the weather. There, the gas turns into tiny droplets of acid that reflect sunlight back into space. The droplets can stay in the upper atmosphere for 1 to 3 years. While they are there, the sun looks dimmer and the earth gets colder. So, the answer was a volcano. Question solved. Except for one problem. Nobody could figure out which volcano. For the next 30 years, scientists searched. El Salvador was a candidate. So was the island of Krakatoa. Nobody had a clean match. And then, in 2018, a Harvard historian named Michael McCormick decided to look at the wrong ice core. The famous Greenland ice cores were too far away from the volcano. Too much had blurred between the eruption and the snow. McCormick's team went instead to a glacier in the Swiss Alps. They used a new technique that could see the chemical composition of every individual particle trapped in the ice at incredibly high resolution, particle by particle. When they looked at the 536 layer, the answer was sitting there. The volcanic ash particles had the chemical fingerprint of Iceland. And not just one eruption in 536, but at least 2 more, in 540 and 547. A triple sequence. Each one piling more sulfur into the stratosphere before the previous load had cleared out. No previous generation of scientists had been able to see this, because no previous generation had the resolution. The Icelandic eruption of 536 was, on the climate scale, roughly comparable to the legendary explosion of Mount Tambora in 1815. But Tambora only darkened the sky for about a year. The 536 sequence was longer, larger, and stacked on top of itself. Iceland is a chain of volcanic islands sitting directly on a tectonic boundary. Eruptions there are common, but small. Once or twice in every couple of millennia, one of them goes off catastrophically. The 536 events were that kind. And here is the most uncomfortable detail. The exact volcano has still never been positively identified. We know it was Icelandic. We know it erupted in late winter or early spring of 536. We know it was followed by at least 1 and probably 2 more major events within the same decade. But the specific crater, 1,500 years later, has not been named. The thing that nearly ended late antique civilization is still out there, and we do not know what to call it. It is tempting to think of 536 as ancient history, a medieval problem, something that could not happen in a world with satellites and weather forecasts and modern agriculture. But here is the part that should make you pause. The Roman Empire of 536 had been built on hundreds of years of stable climate. So had the empires of Persia, China, and the Maya. None of them expected the sky to break. None of them had a backup plan. They were running on the assumption that next year would look like last year, and that they could keep doing the things they had always done. When the sun dimmed, the assumption broke. Trade collapsed. Cities ran out of food. The empires that survived did so by becoming smaller, poorer, and meaner. The empires that did not survive simply ended. Our civilization today is larger, denser, and more interconnected than any empire of late antiquity. We feed 8 billion people from a small handful of breadbasket regions: the American Midwest, the Ukrainian Black Soil, the Northern Indian Plains. These places feed almost everyone. They are also the exact places most vulnerable to a sudden cold summer. And the Icelandic volcanic system that broke the sky in 536 is still active. In 2024, the University of Iceland warned that the geological pressure under one of its central volcanoes, Katla, is once again building. The dancers of Strasbourg believed their bodies belonged to them. The colonists of Roanoke believed they were building a Little England. The Romans of 536 believed the sun would rise tomorrow with the same brightness it had risen yesterday. It did not. And by the time they understood what had happened, an entire civilization was already falling apart underneath them. The sky still rises every morning. The light still arrives on time. The crops grow because of it. And every empire that has ever assumed that arrangement was permanent has eventually been wrong.